5, 4, 3, 2,
ఏదే ప్రజలు నువ్వా
1, 0.
Hi students, welcome to GM Alamma Anubandha Student Support Program. In the previous video clip, we has been discussed about the concept refraction. Now today, lecturing video, we will see about the determination of refractive index of material of the prism for minimum deviation. And here we are going to find out the angle of minimum deviation for the prism. Okay, and also along with that we are going to determine the refractive index of material of the prism. So before going to discuss about this concept, let us see what is prism. Can you tell me, any one of you, what is prism? Prism andre enu? So you might have observed, so you might have learned in your school days. ನಿಮ್ಮ ಸ್ಕೂಲ್ ಡೇಸಲ್ಲಿ ನೀವು ಇದ್ರ ಬಗ್ಗೆ ಓದಿರ್ಬೋದು. ಓಕೆ, ಸೊ ಪ್ರಿಸಮ್ ಅಂದರೆ ಏನು, ದ ನ್ಯೂಟನ್ಸ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟು. ಓಕೆ, let us see that now. First, what is prism? So now here, let us say this is the prism, or what we are going to observe here. This prism is a solid, transparent and homogeneous and also refraction mediums. These are all what we call that refraction medium. It is bounded by 3 rectangular surfaces and 2 triangle. Okay, so here the 3 rectangular surfaces means this is the one surface, here this is the second, and here this is the third one. Okay, so these 3 are rectangular surfaces. 2 triangle means here upper side one triangle and lower side this is another triangle. These 2 triangles are parallel to each other. Okay, and so once again I will repeat the definition. Prism is a solid, transparent and homogeneous and also refracting medium bounded by 3 rectangular surfaces and 2 triangular surfaces. These 2 triangle surfaces are parallel to each other. Now here, look at here. So these 2 rectangular surfaces are here. For example, if the light ray incident at this point, this is the light ray. If the light ray is incident at this point, means the light ray is entering in this refracting surfaces. So inside there is a glass medium. Because of change in medium, it undergoes a refraction. Again, it emerges out from this surface. This surface in the emerges aguntadu. That means now the angle between that incident refracting surfaces and emergent refracting surfaces is called enanta karitu ನಾವು angle of the prism. Remember, it's very important. The angle between that incident refracting surfaces and emergent refracting surfaces is called angle of the prism, or that is also called apex angle. So here this is the apex angle. This side bantu the apex angle. So downward here, this one what we call the base of the prism. ಈ ಟ್ರಯಾಂಗಲ್ ಸರ್ಫೇಸನ್ನು ನಾವು ಜಸ್ಟ್ ಪ್ರಿಸಮ್ನ ಬೇಸ್ ಮಾಡ್ಬೋದು, ಬಟ್ ಈ ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಸರ್ಫೇಸ್ ಇದಾವಲ್ಲ, ಸೊ ದೀಸ್ ಆರ್ ಆಲ್ ವಾಟ್ ವಿ ಕಾಲ್ ದಟ್ ರಿಫ್ರಾಕ್ಟಿಂಗ್ ಸರ್ಫೇಸಸ್. ಓಕೆ, ಸೊ ಲೈಟ್ ರೇ ಇಲ್ಲಿ ಎಂಟರ್ ಆದರೆ ಇಲ್ಲಿ ಡಿವೇಟ್ ಆಗುವಂಥದ್ದು, ಅಂದರೆ ಸೊ ಎಮರ್ಜೆಂಟ್ ಆಗುವಂಥದ್ದು. ಬಟ್ ನಾವು ಯಾವುದೇ ಕಾರಣಕ್ಕೆ ಪ್ರಿಸಮ್ ಈ ಥರ ಪ್ಲೇಸ್ ಮಾಡಬಾರ್ದು. ಈ ಥರ ಪ್ಲೇಸ್ ಮಾಡಿದರೆ ದೆರ್ ಈಸ್ ನೋ ರಿಫ್ರಾಕ್ಷನ್ ಫಿನಾಮಿನಾ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. ವೈ? ಬಿಕಾಸ್ ದೀಸ್ ಆರ್ ಆಲ್ ರಿಫ್ರಾಕ್ಟಿಂಗ್ ಸರ್ಫೇಸಸ್. ಓಕೆ, ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಸರ್ಫೇಸಸ್ ಆರ್. ನೌ ಲೆಟ್ ಅಸ್ ಸೀ ದಟ್ the angle of minimum deviation for this prism. ಹಾಗಾದ್ರೆ ಮಿನಿಮಮ್ ಡಿವಿಯೇಷನ್ ಏನಿದೆ ಈ ಪ್ರಿಸಮ್ಗೆ? ಸೊ ಟುಡೇ ಕ್ಲಾಸಲ್ಲಿ ಇದ್ರ ಬಗ್ಗೆ ನಾವು ತಿಳ್ಕೊಳ್ಳೋಣ. ಸೊ ಫಸ್ಟ್, ಸೊ ಲೆಟ್ ಅಸ್ ಸಿ ದಟ್, ಲೆಟ್ ಮಿ ಎಕ್ಸ್ಪ್ಲೇನ್. ಸೊ ಹೌ ಟು ಡ್ರಾ ದಿಸ್ ಪ್ರಿಸಮ್. ಈಗ ಪ್ರಿಸಮನ್ನು ಯಾವ ಥರ ನೀವು ಡ್ರಾ ಮಾಡ್ತೀರ ಅಂತ ಹೇಳಿದ್ರೆ, ಹಿಯರ್ ಒನ್ ಟ್ರಯಾಂಗಲ್ ಆ್ಯಂಡ್ ಅಪ್ಪರ್ ಸೈಡ್ you consider one more triangle. So now you join the edges. Okay, so this is the first refracting surface. This is first refracting surface. here this one, this side is second refracting surface, second refracting surface. So this what we call the base of the prism. ಇದೇನಂತ ಕರಿತೀವಿ ನಾವು base of the prism ಅಂತ ಕರೆಯುತ್ತದೆ. Here this angle, this is the angle what we call apex angle or angle of the prism. That angle is called apex angle or angle of the prism. That means here if we locate this prism, okay, ಈ prism ಅನ್ನು ಈಗ ನೀವು ಇಲ್ಲಿ locate ಮಾಡಿದ್ರೆ, okay, so now here this is the first refracting surface, okay, ಈ ಕಡೆ ಸೈಡ್ ಇರೋದೇನಿದು first refracting surface. Here this is the second refracting surfaces. ಫಸ್ಟ್ ರಿಫ್ರಾಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ ಲೈಟ್ ಇನ್ಸಿಡೆಂಟ್ ಆದರೆ ಸೆಕೆಂಡ್ ರಿಫ್ರಾಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಎಮರ್ಜಸ್ ಆಗುತ್ತೆ. ಆಂಗಲ್ ಬಿಟ್ವೀನ್ ದಿಸ್ ಟು ಇನ್ಕ್ಲೈನ್ಡ್ ರಿಫ್ರಾಕ್ಟಿಂಗ್ ಸರ್ಫೇಸಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಂಗಲ್ ಆಫ್ ದಿ ಪ್ರಿಸಮ್ ಆರ್ ಅಪೆಕ್ಸ್ ಆಂಗಲ್. And here this is the base of the prism. Okay, so this is all about what the fundamental concept regarding about the prism. And now our intention is to calculate so determination of refractive index of a material of the prism. ಓಕೆ, ಅದ್ರ ಜೊತೆಗೆ ಅದಾದಮೇಲೆ ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ನಾವು, ಮಿನಿಮಮ್ ಡಿವಿಯೇಷನನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿರೋಂಥದ್ದು. ಓಕೆ, ಸೊ ನಾವು ಲೆಟ್ ಅಸ್ ಸೀ ಅಬೌಟ್ ದಟ್ ಮಿನಿಮಮ್ ಡಿವಿಯೇಷನ್ ಆಫ್ ದ ಪ್ರಿಸಮ್. ಸೊ ಪ್ಲೀಸ್ ರೈಟ್ ದ ಡಯಾಗ್ರಾಮ್. ಓಕೆ, ಸೊ ನಾನು ಕ್ಲಾಸಸ್ಸಲ್ಲಿ ಅಂದರೆ ಏನೇನು ಹೇಳ್ತಾ ಬರ್ತಾನೋ ದ ಡಯಾಗ್ರಾಮ್ಸ್ ಅಂಡ್ ಆಲ್ ಯು ಪ್ಲೀಸ್ ರೈಟ್ ಅಲಾಂಗ್ ವಿತ್ ಮೀ. ಓಕೆ, ಸೊ ಜೊತೆಗೆ ಬರ್ಕೊತ ಬನ್ನಿ. Let us consider the principal section of a prism. This is the principal section of the prism. Give the name X, Y, Z. This is the base of the prism. This is what we call that base of the prism. Principal section of the prism. Okay. So base of the prism, and here this is the principal section of the prism. Once again I am saying please write along with me diagrams na jote barkonta bani. So now let us consider a light ray, and before that here this is angle of the prism. This is angle of the prism that is denoted by the letter A. A is the angle of the prism or apex angle. Light ray is incident. Now let us consider a light ray. The name of the light ray PQ. Okay, PQ is the incident light ray. Meet at this point Q. So now here there is an air medium. Inside here there is a glass medium. Because of change in medium, here the light ray undergoes refraction phenomenon. Okay, if there is no change in medium means light ray would have traveled in this path. Light ray ಏನಾಗಿತ್ತು ಈ ಪಾತಲ್ಲಿ ಟ್ರಾವೆಲ್ ಆಗ್ತಾ ಇತ್ತು. If there is no change in medium, but because of change in medium, so light ray is refracted in this direction. So let us give the name here. This is the here PQ is the incident light ray, QR is the refracted ray. Once again here what happens, there is a change in medium. If there is no medium means light ray would have traveled in this path. Ee path alli light ray hogಬೇಕಾಯಿತು. But because of change in medium again light ray is deviated. So let us take this is RS is the emergent light ray, PQ is the incident light ray, QR is refracted ray, RS is emerged light ray. Now to know the angle of incidence, let us draw a normal at the point Q. Let us draw a normal at the point Q to calculate the angle of incidence. Similarly here also the same at a point R. ಸೊ ನಾರ್ಮಲನ್ನು ಡ್ರಾ ಮಾಡಿ. ಈ ನಾರ್ಮಲ್ ಏನಕ್ಕಪ್ಪ ಅಂತ ಹೇಳಿದರೆ ಟು ನೋ ದ ಆ್ಯಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಅಟ್ ಎ ಪಾಯಿಂಟ್ ಕ್ಯೂ ದ ಆ್ಯಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಈಸ್ I1. I1 is the angle of incidence. So now here if there is no change in medium means light ray would have traveled in this path, but because of change in medium light ray ಏನಾಗಿದೆ ಈ ಪಾತಲ್ಲಿ ಹೋಗಿರುವಂಥದ್ದು. ಓಕೆ, ಸೊ ನಾವು ಹಿಯರ್ ಹೌ ಮಚ್ ಇಟ್ ಈಸ್ ಡಿವಿಯೇಟೆಡ್. ಓಕೆ, that is denoted by D1, the deviation by the light ray. ಸೊ ಲೈಟ್ ರೇ ಏನಾಗಿದೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಏನಾಗಿದೆ ಬೆಂಡ್ ಆಗಿರೋಂಥದ್ದು. ಸೊ ರಿಫ್ರಾಕ್ಟೆಡ್ ರೇ, ಗಿವ್ ದ ನೇಮ್ R1. So like that here at a point R, once again the light ray is incidenting on this XZ surface. The point of incidence is R. Here the angle of incidence at a point R, so we are going to take it as R2 for our convenient purpose. Why? Because here we given the name R1. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಏನು ತೊಗೊತಿದ್ದೀನಿ, ಈ ಆರ್ ಹತ್ರ ಲೈಟ್ ರೇ ಏನಾಗುತ್ತೆ ಇನ್ಸಿಡೆಂಟ್ ಆಗುತ್ತೆ ಈ ಪಾಯಿಂಟ್ ಹತ್ರ, ಅಲ್ಲಿ ಆ್ಯಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ನ ಯಾವುದರಿಂದ ಡಿನೋಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ R2. So actually if there is no change in medium means light ray would have traveled in this path, but because of change in medium light ray is deviated. Okay, so this is the deviation day 2. So now the total angle light ray ಎಷ್ಟು angle ಇಂದ emergent ಆಗಿದೆ ಅಂದರೆ from the normal to this emergent light ray RS, this is the emergent light ray, so that is E, which is equals to I am going to take it as I2. Why? Because here initially the angle of incidence is given by the letter I1, so finally emergent light ray we are going to denote it by the symbol I2. But here our intention is to calculate the minimum deviation. What is this minimum deviation means? Here if we extended this emergent light ray, ಈ emergent light ray ನ ನೀವು extend ಮಾಡಿದರೆ, so here this is the emergent light ray. So the extended incident light ray and extended emergent light ray both are meet at this point. So this what we call minimum deviation dou. ಸೊ ಲೈಟ್ ರೇ ಎಷ್ಟು ಆ್ಯಂಗಲಿಂದ ಬೆಂಡ್ ಆಗಿದೆ. ಸೊ ಆ್ಯಕ್ಚುಲಿ ಏನಾಗಿತ್ತು ಲೈಟ್ ರೇ, ಸೊ ಪಿ ಕ್ಯೂ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿರೋಂಥ ಲೈಟ್ ರೇ ಸೊ ಈ ಪಾತಲ್ಲಿ ಹೋಗಬೇಕಾಗಿತ್ತು, ಬಟ್ ಬಿಕಾಸ್ ಆಫ್ ಚೇಂಜ್ ಇನ್ ಮೀಡಿಯಮ್ ಸೊ ಈ ಥರ ಹೋಗ್ಬೇಕಾಗಿರೋ ಲೈಟ್ ರೇ ಏನಾಗಿದೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ, ಸೊ ಇಟ್ ಈಸ್ ಡಿವಿಯೇಟೆಡ್. ಸೊ ಇಷ್ಟು ಡಿವಿಯೇಷನ್ ಆಗಿರೋವಂಥದ್ದು. ಓಕೆ, ಸೊ ಈ ಎಷ್ಟು ಡಿವಿಯೇಷನ್ ಇದನ್ನು ನಾವೇ ಮಾಡಬೇಕಾ. ಸೊ ನಾವು ವಿ ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಟ್. ಇದನ್ನು ಈಗ ನಾವೇ ಮಾಡಬೇಕು, ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗಿರೋಂಥದ್ದು. ಸೊ ಫಾರ್ ದಟ್ ಪರ್ಪಸ್ now let us consider a quadrilateral. So what is the quadrilateral means? AQNR. So now onwards please you look at the diagram. So diagram ಅನ್ನು ಭಾಳ ಕೇರ್ಫುಲ್ಲಾಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾ ಬನ್ನಿ. ಸೊ ಡಯಾಗ್ರಾಮ್ ಕೇರ್ಫುಲ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾ ಬಂತ ಹೇಳಿದ್ರೆ ಸೊ ಬರೆಯೋಂಥ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಸ್ಟೆಪ್ಸ್ ನಿಮಗೆ ಬೇಗ ಸ್ಟೆಪ್ ಬೈ ಸ್ಟೆಪ್ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗ್ತಾ ಬರುತ್ತೆ. ನಾವು in the quadrilateral AQNR, ಸೊ ಕನ್ಸಿಡರೇಷನ್ ಪಾರ್ಟ್. ಓಕೆ, ಐ ವಿಲ್ ಶೇರ್ ದ ನೋಟ್ಸ್. ಆ ನೋಟ್ಸಲ್ಲಿ ಇರುತ್ತೆ ಏನು ಕನ್ಸಿಡರೇಷನ್ ಅಂತೇಳಿ. ಸೊ ಪಿ ಕ್ಯೂಬ್ ಇಸ್ ದ ಇನ್ಸಿಡೆಂಟ್ ಲೈಟ್ ರೇ, ಕ್ಯೂ ಆರ್ ಇಸ್ ದ ಎಮರ್ಜೆಂಟ್ ಲೈಟ್ ರೇ, ಕ್ಯೂ ಆರ್ ಇಸ್ ದ ರಿಫ್ರಾಕ್ಟೆಡ್ ಲೈಟ್ ರೇ, ಆರ್ ಎಸ್ ಇಸ್ ದ ಎಮರ್ಜೆಂಟ್ ಲೈಟ್ ರೇ, I1 is the angle of incidence, I2 is the angle of emergence. D1 and D2 are the deviation by the light ray. So incident and refracted light ray deviations. R1, R2. Okay, R1 is the angle of refraction at a point Q, R2 is the angle of incidence at a point R. So now in quadrilateral, AQNR, in a quadrilateral AQNR, look at the diagram AQNR. Okay, so a quadrilateral diagram ಬೇಕಾದರೆ, so here this is the quadrilateral A, opposite angles, here this is QNR. AQNR is the quadrilateral. In this quadrilateral AQNR, the angle A plus angle, here you give the name. What is the name you are going to give means that is N, angle N, angle AQNR. AQNR is the quadrilateral. In that quadrilateral opposite angles A and N, these are sum of the opposite angles. Okay, so sum of the opposite angles in the quadrilateral, how much it is? 180 degree. Okay, so angle A angle A plus QNR. How much here it is? 180 degree. Let us call this is the equation number 1. So now to calculate QNR, so QNR can be written as 180 degree minus angle of the prism A. Let us call this is the equation A. So now look at the triangle. So now in the triangle, what is the triangle? It is the name of the triangle. So now the triangle QNR. If you consider the triangle QNR, in this triangle QNR here, diagram of the triangle QNR. The angle here R1, here the angle is R2, here the angle N. The sum of interior angle in a triangle. Okay, so what is the total angle? The sum of the total angles, interior angles in a triangle it is. Okay, so that is equals to how much? 180 degree. That is R1 plus R2 plus QNR, which is equals to 180 degree. So let us call this is the equation number 2. So now by using equation A, using equation number A, okay, so now this can be written as here in the place of QNR. What is the QNR? 180 degree minus A. Okay, so if you substitute that value R1 plus R2, so plus QNR 180 degree minus angle of prism A, which is equals to 180 degree. Now this plus 180 degree. So right hand side bandre minus 180, plus 180 minus 180, 0. So minus A, right RHS side bandre plus A. So that here the angle of refraction R1 plus angle of incident at the second surface R2, which is equals to the angle of prism A. Let us call this is the equation number 3. That is the equation number 3. So now our intention is to calculate the deviation, to find total deviation, So what this total deviation means? D is equals to D1 here. The deviation is denoted by the symbol dou. Okay, why? Because here we taken that symbol represented by that is dou. Okay, so D is equals to D1 plus D2. ಸೊ ನಾವು ಇಲ್ಲಿ ಎಷ್ಟು ಡಿವಿಯೇಷನ್ ಆಗಿದೆ ಲೈಟ್ ರೇ ಅಂತ ಹೇಳಿದ್ರೆ ದಟ್ ಈಸ್ D1 ಪ್ಲಸ್ D2. ಅಂದರೆ ಇಲ್ಲಿ ಎಷ್ಟು ಡಿವಿಯೇಷನ್ ಆಗಿದೆ D1 ಆ್ಯಂಡ್ ಇಲ್ಲಿ ಎಷ್ಟು ಡಿವಿಯೇಷನ್ ಆಗಿದೆ ದಟ್ ಈಸ್ D2. ಇವೆರಡನ್ನ ನಾವೀಗ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದೋಸ್ ಟು ವ್ಯಾಲ್ಯೂಸ್ ಇಯರ್ ಲುಕ್ ಅಟ್ ದ ಡಯಾಗ್ರಾಮ್ ವೆರಿ ಕೇರ್ಫುಲಿ. ಸೊ ಡಯಾಗ್ರಾಮನ್ನು ಕೇರ್ಫುಲ್ಲಾಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾ ಬನ್ನಿ. ಸೊ ಹಿಯರ್ ಐ ವಿಲ್ ರೈಟ್ ಇಟ್ ಹಿಯರ್. ಸೊ ಲಿಸನ್ ರಫ್ಲಿ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ರೈಟ್ ದಿಸ್ ಈಸ್ ದ ಲೈಟ್ ರೇ PQ, the normal at this point. Light ray would have traveled in this path, but because of change in medium it's get refracted. This is the deviation D1. Okay, so this is the refraction R1. This is the angle of incidence I1. Now in this diagram look at that angle I1 is equals to this total angle. What is this total angle? R1 plus D1. So now I1 can be rated as R1 plus D1 or D1 ಅಂದ್ರೆ ಏನಂತ ಬರಿಬೋದು? So what we can able to write I1 minus R1. D1 ಅಂದ್ರೆ ಏನು? I1 minus R1. So what is the D1 now? I1 minus R1. So like that now if you come to the second surface, this is the second surface, the light ray is incidenting like this. If you draw a normal at the point of incidence, okay, so now this is the angle R2. If there is no medium, light ray would have traveled in this path, but because change in medium it is refracted in this direction. This is the deviation D2. So this is the angle of emergent, the total angle, how much it is? I2. This R2 angle, look at the diagram carefully. Here in this R2 angle, here it is, this R2 angle is equals to this angle ಏನಕ್ಕೆ equal ಆಗಿರುತ್ತೆ ಈ angle ಈ angle opposite angle, these two are opposite angle. R2 angle is equals to this much of angle, that is this much of angle means I2 minus D2. Here I wrote that, okay. R2 is equals to I2 minus D2. R2 ಅಂದರೆ ಎಂತ ಬರೀಬಹುದು ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ I2 minus D2 ಅಥವಾ D2 ಅಂದರೆ ಏನು. So D2 can be written as, so D2 can be written as minus D2 ಈ ಕಡೆ ಬಂದರೆ plus D2, that is I2 minus R2. Yes, please write it here. So D1 ಅಂದರೆ I1 minus R1, D2 can be written as I2 minus R2. So that now the total deviation becomes, I will rub this here, this is not required for you, ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಲಿ ಅಂತ ಹೇಳಿದ್ರೆ ಅಷ್ಟೇ. So now the total deviation though can be written as by substituting these two values. D1 I1 minus R1 plus D2 I2 minus R2. Here I1 plus I2 remaining minus R1 minus R2. So minus sign common ತೆಗೆದ್ರೆ so I1 plus I2 remaining here ಇಲ್ಲಿ minus sign common ತೆಗೆದ್ರೆ ನೀವು, so remaining we have R1 plus R2. So here it is, what is R1 plus R2? So that is equals to A. So now using equation number 3, so this equation can be written as dou is equals to I1 plus I2 minus R1 plus R2 ಅಂದರೆ angle of the prism A. Let us call this is the equation number 4. So this is the total deviation produced in a prism. Total deviation this is I1 plus I2 minus A, that is equation number 4. Now our intention is to calculate minimum deviation. So what is this minimum deviation means? Now if we plot a graph, so listen carefully, this graph is an important for you. Entire derivation is based on this graph. This is the angle of incidence along x-axis, along y-axis is angle of deviation. So ಇಲ್ಲಿ ನಾವು ಆ್ಯಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸನ್ನು ಚೇಂಜ್ ಮಾಡ್ತಾ ಆ್ಯಂಗಲ್ ಆಫ್ ಡಿವಿಯೇಷನ್ ಗ್ರಾಫ್ ಪ್ಲಾಟ್ ಮಾಡಿದರೆ, ಸೊ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪರ್ಫಾರ್ಮ್ ದಿಸ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಇನ್ ಯುವರ್ PUC ಪ್ರಾಕ್ಟಿಕಲ್ಸಲ್ಲಿ ಇದೆ, ಓಕೆ, ಆಪ್ಟಿಕ್ಸಲ್ಲಿ. ಸೊ ಬರುವಂಥ ಎಕ್ಸ್ಪೆರಿಮೆಂಟು, ಆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಪರ್ಫಾರ್ಮ್ ಮಾಡಿ ನೀವು ಈ ಗ್ರಾಫನ್ನು ಪ್ಲಾಟ್ ಮಾಡ್ತೀರಾ. So now if you plot a graph, angle of incidence versus angle of deviation means initially when the angle of incidence increases means the angle of deviation decreases. Thereafter it start to increases. Okay, so ಏನಾಗುತ್ತೆ, angle of incidence increase ಆದಂಗೆ deviation decrease ಆಗ್ತಾ ಬರುತ್ತೆ, that is up to one certain value. Thereafter angle of incidence increases, once again it is increasing, angle of incidence means the deviation also start to increases. This point what we call that minimum deviation, ಇದನ್ನ ಏನಂತ ಕರಿತೀವಿ ನಾವು, minimum deviation, that is DM. So now in this graph, if we initially the first 3 points are there based on this graph. The first point it is when the angle of incidence increases, the deviation decreases. After a minimum deviation again it start to increases. Second, for every angle of incidence, look at here, for every angle of incidence, not for every angle of incidence, here if we take deviation, for every angle of deviation there are 2 angle of incidence. Are you agree with this statement? For every angle of deviation there are 2 angle of incidence wherever you go, okay. So for example here the deviation I am going to take some 50 degree means here the angle of incidence initially 20 degree and here it is some 55 degree. Look at here, the deviation is same, okay, 50 degree, but angle of incidence at this point 20 degree and here it is 55 degree. So that is the reason why for every angle of deviation there are 2 angle of incidence. But if you come to that at minimum deviation, even when you come to the minimum deviation, okay, here if it is I1 and here I2, but at the minimum deviation, look at here, so what is the minimum deviation value? There is only 1 point or only one value for the minimum deviation and angle of incidence. there is only one angle of incidence for minimum deviation, but other than minimum deviation there are two angle of incidence for every angle of deviation. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಸೊ ಮಿನಿಮಮ್ ಡಿವಿಯೇಷನ್ ಹತ್ರ ಏನು, ಸೊ ಒಂದು ಮಿನಿಮಮ್ ಡಿವಿಯೇಷನ್ ಅಂದರೆ ಈ ಪಾಯಿಂಟ್ ಹತ್ರ ಒಂದೇ ಆ್ಯಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸು, ಬಟ್ ಈ ಪಾಯಿಂಟ್ ಬಿಟ್ಟು ಬೇರೆ ಯಾವುದೇ ಪಾಯಿಂಟಿಗೆ ಬನ್ನಿ ನೀವು, ಓಕೆ, ಇಫ್ ಯು ಕನ್ಸಿಡರ್ ಇಯರ್, ಓಕೆ, ಸೊ ಲುಕ್ at here at this point look at here, angle of incidence is going to be changes. There are two angle of incidence, I1, I2, but here it is I1 is equals to I2, okay, so both the two angles, okay, only one angle of incidence at the point of minimum deviation. So that is the reason why we are going to write that I1 is equals to I2, which is equals to I. So similarly we can able to write for refraction R1 R2 which is equals to R. So by using this, okay, ಈ ರಿಲೇಷನ್ಶಿಪ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಿ, so now look at it, the equation number 4 implies that now, so what is the equation number 4 tells that, so dou is equals to, dou is replaced by minimum deviation dm. In the minimum deviation I1 is equals to I2 which is equals to I1 plus I2 ಅಂದರೆ, ಓಕೆ, ಸೊ I plus I, ಯಾಕಂದರೆ I1 is equals to I2 is equals to I ಆಗಿರೋದ್ರಿಂದ I1 plus I2 means it is I plus I plus I means how much, 2I, so deviation of it becomes 2I minus A, okay, so this is the minimum deviation formula dm. ಆರ್ ಸೊ ಈ ಮೈನಸ್ ನೀವು ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ತೊಗೊಂಬಂತ ಹೇಳಿದ್ರೆ, ಸೊ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ದಟ್ ಈಸ್, ಸೊ ಡಿ ಎಮ್ ಪ್ಲಸ್ ಎ ವಿಚ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು 2i, ಆರ್ ಐ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಎ ಪ್ಲಸ್ ಡಿ ಎಮ್ ಡಿವೈಡೆಡ್ ಬೈ 2, ಐ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು a plus dm divided by 2, that is the angle of incidence, okay, so like that if you come to that equation number, look at the equation number 3. Now this equation number 3 tells that R1 plus R2 is equals to A, R1 is equals to R2 is equals to what, R, so that here it is R1 ಅಂದರೆ R, R2 ಅಂತ ಹೇಳಿದ್ರೆ that is also equals to R, R plus R 2R is equals to A, okay, so R plus R it is, that is 2R which is equals to A, or R is equals to A divided by 2. So now this is the angle of incidence I value, this is the refractive angle, that is R is equals to A divided by 2. Once again you look at it, R is equals to A divided by 2. So now here for this we are going to use, okay, so here we calculated the angle of incidence I and refraction angle, that is R is equals to A by 2. The Snell's law formula you know that here. Next you are going to implement the Snell's law. So we know that Snell's law. So what is the Snell's law means here? For the first refractive surface here, the air medium refractive index is mu1, the glass medium refractive index is mu2, or you take refractive index as n1. Why? Because your NCERT textbook they mentioned n1 and n2. So now the refractive index n1 sin I which is equals to n2 sin R, sin I divided by sin R, sin I divided by sin R which is equals to, okay, so n2 divided by n1, or so refractive index of second medium with respect to the first medium. So now here this n21 is equals to sin I divided by sin R. For air medium, n1 is equals to 1, n2 is equals to, for glass medium the refractive index as n, so that we can able to write here, so n2 as n divided by n1 is equals to 1, so that it becomes now n2 is equals to what we taken n, so that here this formula becomes, so n agutte here we were taken, that is n2 divided by n1 n2 is equals to n, n1 value becomes 1 andre, so n is equals to sin I divided by sin r. Now substituting the value, I value, what is the I value? A plus dm divided by 2, and r value a divided by 2. So now if I substitute that value, sin of a plus dm divided by 2, minimum deviation, divided by sin of r, a divided by 2. Okay, so this is the refractive index. So refractive index of material of the prism for minimum deviation. Okay, so n is equals to sin of a plus dm divided by 2, so whole divided by sin of a by 2. One of the important, the very important 5 mark question, the best. Okay, ಯೂನಿಟ್ ಅಲ್ಲಿ ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿರೋಂತಹ ಒಂದು 5 mark ಕ್ವಶನ್ ಇದು ಪ್ರಿಸಮ್ ಇದು. Yes, my dear students, so once again, so I will repeat here. So whatever we are going to do the derivation means, first listen, first you are going to consider the quadrilateral AQNR. The sum of opposite angles in the quadrilateral, angle A plus angle QNR is equals to 180 degree. Thereafter we taken QNR triangle, R1 plus R2 plus QNR is equals to 180 degree. By using those two equations, okay, so by using those two equations, we wrote R1 plus R2 is equals to A, and thereafter we went to calculate the minimum deviation D1 and D2. For the diagram here, the D1 can be written as, so what is the D1? I1 minus R1. This total angle is equals to R1 plus D1, so that here D1 can be rated as I1 minus R1. Like that in this diagram, at this point R2 can be rated as, okay, so I2 minus D2, that is deviation can be rated as R2 minus I2 minus R2. So already I shown that. So thereafter, so by calculating the total deviation, we plot a graph. Here the 3 points are there in this graph. First, when the angle of incidence increases, deviation decreases, thereafter it start to increases. Second one, for every angle of deviation, there are 2 angle of incidence wherever you go. Okay, for one angle of deviation, there are 2 angle of incidence. But the third point, at the minimum deviation, okay, so ಒಂದೇ minimum deviation ಇರುವಂತದ್ದು, ಆ minimum deviation ಗೆ ಒಂದೇ angle of incidence ಇರುವಂತದ್ದು. Okay, so this is the graph you are going to observe. So while doing the experiment, when you plot a graph, angle of incidence ವರ್ಸಸ್ ಡಿವಿಯೇಷನ್ ಎರಡು ನಡುವೆ ನಾವು ಗ್ರಾಫ್ ಪ್ಲಾಟ್ ಮಾಡಿದರೆ ಈ ನೇಚರ್ ಆಫ್ ಗ್ರಾಫ್ ಬರುತ್ತೆ. ದಿಸ್ ಗ್ರಾಫ್ ಈಸ್ ನಾಟ್ ಎ ಸಿಮಿಟ್ರಿ ಆರ್ ಲೀನಿಯರ್ ಆರ್ ಪೆರಾಬೋಲಾ ಆರ್ ಹೈಪರ್ಪೆರಾಬೋಲಾ. ಓಕೆ, ಸೊ ಈ ಗ್ರಾಫಲ್ಲಿ ಸೊ ನಾವು ತಿಳ್ಕೊಂಡಿದ್ದೇನಪ್ಪ ಅಂದರೆ ಮಿನಿಮಮ್ ಡಿವಿಯೇಷನ್ಗೆ ಒಂದೇ ಆ್ಯಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಇರುತ್ತೆ ಅಂತೇಳಿ. ಅದಾದ ನಂತರ ಸೊ ವೆನ್ I1 I2 ವ್ಯಾಲ್ಯೂ ಬಿಕಮ್ಸ್ I ಮೀನ್ಸ್ ಅಟ್ ದ ಮಿನಿಮಮ್ ಡಿವಿಯೇಷನ್, ರಿಮೆಂಬರ್ ಅಟ್ ದ ಮಿನಿಮಮ್ ಡಿವಿಯೇಷನ್. So I is equals to A plus Dm divided by 2 and R is equals to A by 2. So those two values, if you substitute in the Snell's law, we have this equation. So next class I will continue with this concept. Today it's enough. Thank you.